Hello everyone, welcome back to Spectrum Classes. In this video, I am going to perform the lab activity related to the experiment to determine the equivalent weight of iron by chemical displacement method. Right, so this is the aim of the experiment. This experiment is divided into following sections. One is preparation of solutions, standardization of sodium thiosulfate because this is an iodometric titration. The next is titration of copper sulfate solution before and after. And the last one is calculation and results. In this, we are also going to calculate the percentage error. Now I am going to show you the lab activity related to the preparation of solution and subsequent steps. So let's start with the lab activity. I am preparing the solution of copper sulfate. It is pentahydrated copper sulfate and its molecular weight is 249.68 grams per mole. So to prepare 100 ml solution of m by 10 concentration, I have taken 2.5 grams of copper sulfate. I am first preparing this copper sulfate solution. Now after dissolving it, make up the solution up to the mark. So this is m by 10 copper sulfate solution. So before using it, I shake it well. Now after shaking it thoroughly, I am just transferring 50 ml of this copper sulfate solution in the measuring cylinder, and this 50 ml I am going to transfer in the beaker, and in this beaker I am going to transfer this strips of iron. So here are the rusted iron strips and this is the clean iron strip. Now I'm going to first weight of this iron strip. So make it 0 first. And now weight this iron strip before dip this iron strip into the copper sulfate solution. So this is 21.784 grams without before putting it in the copper sulfate solution. Now I put it in the copper sulfate solution which I have prepared. In between we are preparing the sodium thiosulfate solution because this is iodometric titration. So for that purpose we require sodium thiosulfate solution as I told you earlier in the starting of the video. So I am just going to prepare m by 10 sodium thiosulfate solution and its molecular weight is 248 grams. And I am going to prepare it in 500 ml. So first, since I do not have 500 ml container, so I first dissolve it into 250 ml measuring flask, and then again I am just transferring 250 ml of distilled water in this reagent bottle. So I make up it up to 500 ml sodium thiosulfate solution. So this is my m by 10 sodium thiosulfate solution. Now to standardize this sodium thiosulfate solution, I am going to prepare m by 10 K2Cr2O7 solution. Meanwhile, you can see the reaction of iron strip and copper sulfate solution. So this is half an hour. Now starch solution is also needed to be prepared freshly. So I am going to prepare starch solution for which I am just going to take 1 gram of starch and I am going to dissolve it in the 100 ml. So to prepare starch solution, first you dissolve it in some cold water and then pour this slurry into the boiling water. So detailed procedure I am not going here. So I am just going to pour it in the hot water and then boil for 2-3 minutes, and after cooling it down to room temperature, after cooling I am just going to filter it in the reagent bottle. and this will be used as internal indicator for iodometric titrations. This is my starch solution. Now I am going to fill it. Fill this nozzle also, right? Don't bother about the mark. Now make up it up to the mark. Now this sodium thiosulfate solution is going to be titrated against or standardized against K2Cr2O7 solution. So for that purpose I am just going to rinse my conical flask. And taking 10 ml of this. Now to this K2Cr2O7 I am just going to add some acid H2SO4, and to this I am just going to add potassium iodide, and here you see the change in color. I leave it at after covering it for 2-3 minutes so that iodine is released. Here you can see the mark, and I am going to titrate it. Nearby the endpoint we are using the starch solution after when the color of this solution is going to be fainted. Now we are going to titrate our copper sulfate solution. Now I again rinse the conical flask with this copper sulfate solution, and I'll take 10 ml of. Now I'm going to transfer it in the conical flask, and I'm going to add potassium iodide. You can see the change in color. So iodine is released immediately, but I leave it for 2-3 minutes after covering it with the help of petri dish. Now I'm going to start titration. So I'll take the initial reading, which is 0. When this color is getting to be fainted, at that moment I am going to add the starch. Now I am going to add the starch solution which we have prepared freshly, and you see the purple color complex of starch iodine. Now again start titration. So here you should be very careful, and this is the end point. But to ensure the end point, I am just going to add 1 ml of 10% KSCN solution. Potassium thiocyanate 10%. So I have taken 1 gram of potassium thiocyanate in 10 ml. And now I again start titrating. So it becomes white near the end point, and the final reading is 11.6 ml. Now I will remove this iron strip, and I have noted the time. So it takes 1.5 hours. Now I'm going to rinse the conical flask again with this solution, and I'm going to take 10 ml of this solution, which is also having some Fe2 plus ions in the solution form, and initial concentration of calcium is depleted in this solution. So I'm going to titrate it again. again following the same procedure. So I am going to add 1 gram of potassium iodide to this. You can see the color. I will leave it after covering it with the help of petri dish for 2-3 minutes. And now I am going to titrate it again. The initial reading is now, you can see 14 ml. So when this color is get it fainted, I will add starch as an indicator. So here you can see the purple color of starch iodine complex. Now I am going to add 10% SCN solution, potassium thiocyanate solution, just to ensure that all the iodine which is present in the complex form is released and titrated against the sodium thiosulfate solution. Now you can see the end point, 23.6 ml. Here I am just going to take this solution in which iron 2 plus is dissolved. So if iron 2 plus is there, then it will disappear the color of potassium permanganate. Taking in 2 parts, and to this I am just going to add copper sulfate this solution, and you can see the color of potassium permanganate is going to be decolorized. Here you may have a question. It is showing this yellowish blue color. So just to show you that, I am going to add copper sulfate solution to this. So no color change is observed by adding this copper sulfate solution. I am also having iron 3 plus solution. So this is iron 3 solution, and this iron 3 solution I am going to add to this, and you can see the color. Now we are going to compare with iron 2 and iron 3. So this confirms the formation of iron 2 plus ions.